Welcome to the third lecture on altering product strength, and will be a continuation of our alligation alternative method, and we're going to expand and introduce a new way of doing the alligation alternative when you have more than actually two components, so three or more components to include in your alligation. So that's kind of a variation we haven't discussed. And that'll be the last kind of new thing to talk about. Then we'll finish up this lecture with some additional practice problems to continue to hone your skills in using the alligation method for solving these questions when our overall objective, again, is to alter product strength or concentration. So with that as a brief introduction, let's get started with the new component, which is about using the alligation alternative method for when you have three or more ingredients that you're wanting to combine together. And the intent would be to combine these three different concentrations of ingredients to create a new concentration. Okay? What the take-home message is when you have three or more components to use in an alligation, you're going to group them into pairs, and you're going to then repeat the alligation multiple times with these unique pairs of concentrations. Okay? So what you'll do is you're going to use pairs that bracket the desired concentration. That's the key idea. So while you're going to do multiple alligations with multiple combinations, the combination themselves, each of the combinations, have to have one concentration that is higher than the target and one concentration that is lower than the target. So keep that in mind. You choose unique pairs, or you choose pairs to use to perform the alligation, but each pair has to have one concentration higher and one concentration lower than the target. So with that in mind, the actual solving of the alligation is essentially the same, with one more additional step there at the end. So beyond just an overall discussion, let's put this into action and show you an example. So the problem reads, the solvent for the extraction of a vegetable drug is 70% alcohol. In what proportion can 95%, 60%, and 50% alcohol be mixed to prepare the solvent at the desired concentration? And again, we're going to assume no contraction of volume after mixing. Sometimes alcoholic solutions contract their volume a little bit. That's a small effect we're going to ignore here in this problem. So where do we start? We have three ingredients that we want to combine to make a target concentration of 70% alcohol. So the first step, when you have three or more ingredients to combine in an alligation, what we need to do is pick our alligation pairs. That's our first step. To do that, it's important to clearly state what your target concentration is. That is our target, which in this case is 70%. I then suggest kind of writing out or ranking your available ingredients from the highest concentration to the lowest concentration. So we have a 95%, a 60%, and a 50% available. The reason that's important is we have to make our alligation pair such that one concentration is always higher than our target and one is lower than our target. So looking at our options available here, and since there are three ingredients, one of which is higher than the 70% target and two of which is lower. So in this case, our obvious pairs would be to create pair number one with the 95% and the 60%. And pair number two with the 95% and the 50%. Okay? So those are our two pairs. Those are our alligation pairs. So now we're going to set up and essentially solve alligations using those two pairs. So that's our next step, is to actually perform the alligations with each pair. So I'll set up the first example here. Our first pair was to use our high strength 95%, and that's on the upper left. But directly below that, and spaced down a ways, is our lower concentration, which in our first alligation pair was the 60%. So to the right of that and in the middle, we put our target, which was 70%. So again, starting with the upper left with the 95, we're going to follow the arrows down diagonally and cross subtract. So 95 minus 70 equals 25, and that follows down the arrows to the lower right. So we put 95 down there. And then we start again on the lower left with the 60% and go now to the upper right. And following the arrows upwards, we see that we would cross-subtract 70 and subtract 60. And with the result of 10 going up to the top right and we place our value of 10 there. So essentially, and again, with the dashed arrows going sideways, we can see at this point, by doing that cross-subtraction, what we need is 10 parts of our final mixture to be 95% alcohol, and 25 parts of the 60% to be the 60%. So let's do the same thing with the second alligation pair. And again, we're still using the 95% on the top left, which is our high concentration. But this time below that, we're using the lower strength, which was the 50% alcohol. Our target is still 70%. So again, following the arrows and doing our cross subtraction, we can see that 95 minus 70 again is 25. This time, though, going from the lower left up, we would take 70 minus 50, and that would give us the result of 20 parts directly across from the 95. So again, in the second alligation pair, what we're saying is we need 20 parts to be the 95% and 25 parts to be the 50%. Okay, so up to this point, the alligation process is exactly the same. Now, what's a little different is you notice we've stopped by just determining the number of parts for each of the ingredients. We haven't set out of how many total yet. And so this is where it gets a little bit different. What we need to do is summarize and add all the parts together, okay? And this is important because our 95% alcohol is used twice. It's used in both allegations. So let's summarize the parts that we have and then add up our total number of parts. So to summarize, of the 95%, we have 10 parts coming from our first alligation pair and 20 parts coming from our second alligation pair. So if we add those together, the 10 plus the 20, essentially we have, to make this total mixture, we will actually have 30 parts total of 95% alcohol. And hopefully you see that 10 parts come from the first alligation pair, 20 parts from the second alligation pair. Therefore, we have a total of 30 parts of 95% alcohol. Now, the 60% alcohol was only used in the one alligation pair, and it had a total of 25 parts. Likewise, for the 50% alcohol, it too was only used once in one alligation pair and had a total of 25 parts. And that's it. That's all three of our ingredients and the total number of parts from all of the allegations. So now let's add up those individual parts and get a total number of parts. So if we take 30 plus 25 plus 25, that total equals 80 parts. So our total number of parts, it will be 80 parts. So now let's simplify that. Again, it wants to know the proportion. I'll remind you that we're not actually calculating a final volume here in this question. It's a little more simple. But it was wanting just to know essentially individual parts for the individual ingredients and the total number of parts. And basically, you can see in the summary, we've got 30 and 25 and 25 and a total of 80. But let's simplify that because even I can see that an easy number to divide each of those total parts by, or those individual parts by, is 5. So if we divide everything by 5, simply to simplify, then we would get 30 divided by 5 for the 95%, which is 6. And then 25 divided by 5 is 5, and 80 divided by 5 is 16. So a much more simple recipe, if you will, to think about this. Our final answer is, again, to the question that asked, essentially, what is proportions should we mix those? Our answer is, our recipe is to use 6 parts of 95% alcohol, 5 parts of the 60%, and 5 parts of the 50%. If you mix any volume in that ratio, okay, you would end up with a total volume, and that total volume would have a 70% concentration of alcohol. So that essentially answers this first question, which is, again, without going all the way to finding actual volumes for a certain volume of total 70% to create, we've calculated the correct proportions to add all three of our ingredients in so that when they're added in that same proportion, we would end up with 70% alcohol. And that's the answer to this question. Now, before we go on and do some more practice problems, let's prove that this works. We just went ahead and used this alligation in pairs to create a 3-ingredient concentration calculation. But let's prove that it works using the alligation method to prove this, all right? So, if I remind you, what we just determined is that if we used 6 parts of 95%, and add that to 5 parts of 60% and 5 parts of the 50% alcohol, we said that gave us a 70% concentration. To prove that, with the alligation method, our first step is to add all those parts up. So for the individual ingredients, 6 parts of 95 plus 5 parts of 60 plus 5 parts of 50, that ends up with 16 total parts. And while we don't have an actual volume in milliliters, we have parts. So we have a total of 16 parts. Now, let's actually apply and determine the volume of alcohol that would be in those 16 parts. Okay? To do that, and again, this is where it gets weird since we're in parts instead of actually volume in milliliters, let's just multiply the number of parts for each ingredient times its concentration. So starting with the 95%, we had 6 parts. So 6 parts times 95% gives us 570 parts percent. Okay, units just stay together. We don't cancel anything. Okay, same thing for the 60%. 5 parts times 60 is 300 parts percent. And lastly, for the 50%, we also had 5 parts, so 5 parts times 50% gives us 250 parts percent. Now we can add all that up, so 570 plus 300 plus 250 gives us a total of 1,120 parts percent. That's essentially the amount of alcohol in our formulation. To determine the final concentration of alcohol, we take the total amount of alcohol, which we just calculated to be 1,120 parts percent, and divide that by the total volume of our product, which we totaled up to be 16 parts. If we do that, then the units of parts cancel, and we'll end up with just percent. And 1,120 divided by 16 equals 70, meaning our final answer is 70%. So we've just confirmed that if we combine our alcohols in the proportion of 6 parts 95% plus 5 parts 60% plus 5 parts 50%, that combination, regardless of what the actual final volume ends up being, would have a 70% concentration of alcohol, which is what our target was. So once again, we've used the alligation medial method to confirm that our alligation alternative method does work in producing the concentration of alcohol that we desire. All right, let's take a different example and work it all the way through this time instead of just stopping at the proportions. All right, the question reads, how many grams of each product must be used when mixing 20%, 15%, 5%, and lastly 3% zinc oxide ointments in order to produce a total weight of 5,000 grams of an ointment that contains 10% zinc oxide? Okay. So we have 4 different ingredients now, and in the end, these 4 unique concentrations need to be combined in a certain ratio such that in the end, the final total weight will be 5,000 grams and the total final concentration will be 10% zinc oxide. All right, so that's a lot of ingredients. That's certainly three or more, so we can still do the alligation alternative method, but we're going to have to pick some pairs. So let's start off by being organized and writing out that our target concentration is 10%. Our available concentrations ranked from high to low are 20, 15, 5, and 3. Okay? Now we want to choose pairs. And each alligation pair will need to have one concentration higher than 10% and one concentration lower than 10%. Okay? So there are actually 2 different possibilities here because we have 2 concentrations, the 20 and the 15, that are higher, and 2 concentrations that are lower, the 5 and the 3. So we just need to combine those. So what I chose to do for my first pair was to combine the 20% and the 3%. And again, both of those, the 20 is higher and the 3 is lower than our target of 10%. And my second pair was to combine the 15%, which is higher, and the 5%, which is lower than our target of 10%. I certainly could have switched those. You could have done this calculation mixing the 20 and the 5 and the 15 and the 3. That would have worked just as well. But in the end, what is important is that your pairs, by the time you're done making your pairs, you've used each ingredient and you've paired them up such that one of the ingredients in the alligation is higher and one of the ingredients is lower than the target concentration. So in the end, I chose to use the 20 and the 3 for my first pair and the 15 and the 5 for my second pair, which does match that kind of criteria that I just talked about. So now that I've chosen my pairs, I need to go ahead and perform the alligation. So let's set up the alligation for each pair, and I'll do this one at a time again. So for my first alligation pair, I'm setting my high concentration on top. So there's my 20% on the upper left. Directly below that and down a ways, I have my 3%, my low strength. And then in the middle to the right, I've set my target, which was 10%. Starting at the upper left with the 20%, following the arrows down to the lower right, I'm going to cross subtract, so 20 minus 10 gives me 10 parts. Doing the same starting at the 3 and going up diagonally to the upper right, I would take my 10 minus my 3 and end up with 7 parts. And that 7 parts is directly across from the 20%. So what this says, my first allegation pair says I'll need 7 parts of the 20% and 10 parts of the 3%. Okay, that combination would give me 10%. All right, let's move to the second pair. Starting with its higher concentration, which was 15%, I put the 15% on the upper left. Directly below that and down a ways, I put my lower strength, which was 5%. In the middle and to the right, I put my target, which is 10%. Starting with the upper left with the 15%, going down following the arrows diagonally, I will cross subtract. So 15 minus 10 gives me 5. And starting then on the lower left and working following the arrows up diagonally to the upper right, I would take my 10 minus my 5 and get a result of 5 parts, which is placed directly across from the 15%. So again, what I can see now in my second allegation pair is for this combination, I would need 5 parts of the 15% to be mixed with 5 parts of the 5%. So I have now done the allegation for both of my pairs and determined the number of parts of each of the individual ingredients. So let's summarize all 4 of those ingredients and come up with the total number of parts I would need in my formulation. So to summarize, given my 2 allegation pairs, I need 20% of the 20% concentration, I need to use 7 parts. For the 15%, I will need 5 parts. 5% needs 5 parts, and the 3% needs 10 parts. And if I add all of those together, 7 plus 5 plus 5 plus 10, the total number of parts is 27. Okay? And unlike our previous example, looking at those numbers, there's no easier way to simplify our formula. So that's our formula. Our formula essentially says that I need 7 parts of 20% combined with 5 parts 15, 5 parts of 5, and 10 parts of the 3%. I mix those relative weights together. I'd get a total weight that is equivalent to 27 parts, and the final concentration of all of those individuals mixed together would be 10%. Before answering and actually determining the weights, let's go ahead and try to confirm that our calculations this far are correct using the Alligation Method. Let's determine that our formula will in fact create a 10% ointment when we're all done combining our 4 different concentrations. So using the Alligation Method, what we would start with again is to determine the total weight of all of our ingredients. So again, using our recipe that we just determined, we would start with 7 parts of the 20% and add 5 parts of the 15, 5 parts of the 5, and 10 parts of the 3. So if we add 7 plus 5 plus 5 plus 10, again, we get 27 parts. So that's our total weight, again, in parts, but our total weight. Now, let's determine the total weight of zinc oxide in our formulation. To do that, we take the individual parts times its concentration. So for the first ingredient, we would take 7 parts times our 20% to get 140 parts percent. 5 parts times 15 gives us 75 parts percent. 5 times 5 equals 25 parts percent. And lastly, the 10 parts times the 3% gives us 30 parts percent. Now, let's add up all of those numbers. So 140 plus 75 plus 25 plus 30, that summing all of that together gives us a total of 270, and the units are parts percent. So the weight of zinc oxide in our formulation is 270 parts percent. Lastly, to determine the final concentration, we only need to do is take the total amount of zinc oxide, which we just calculated to be 270 parts percent, divided by the total weight, which we said was 27 parts. The units of parts cancel, and 270 divided by 27 gives us a numeric value of 10, and the resulting in the last units would be percent. So again, the Alligation Method tells us that we get a 10% concentration when we mix our products in the order with the number of parts that we've calculated. So we know that our formulation will work and result in a 10% ointment. So now, let's actually go further and actually determine the actual weights we would need. Okay, so let's convert our total number of parts to the individual weights of our product. So again, to summarize, this is what we've calculated was that we needed 7 parts of the 20%, 5 parts of the 15%, 5 parts of the 5%, and 10 parts of the 3%. Okay, so let's use proportions and set up and determine the actual weights for each ingredient. We'll start with the 20% product, and the proportion we're going to set up is simply this. We know that we need 7 parts to be 20%, over a total of 27 parts. All right, those are the ratios we've already set up. That's what our formula says. But our formula is kind of generic. It's not set to create any actual amount. But what we do know in the question is we want all of our ingredients to be combined with a total weight of our final product to be 5,000 grams. So I know, since my total weight is 27 parts, I know that's equal to my 5,000 grams. So we're going to set up that proportion of 7 parts over 27 parts equal to some X value over 5,000 grams. X equals the total weight of the 20% in grams. And again, the total we were given in the question was 5,000 grams. So now I can solve for X. So 7 times 5,000 and then divide that by 27 to solve for X, we would get a total weight of 1,296 grams for the 20% product. And hopefully you can kind of see how that proportion was set up, because essentially we're going to do the same for calculations for each of our ingredients. So moving on to our 15% product, look back at our summary. For the 15%, we were told to use 5 parts. So I'm going to set up my proportion as 5 parts over the total parts, which we are always going to be 27 in this example. Set that equal to some unknown X amount of the 15% over the total, which is never going to change as well in this question, which is 5,000 grams. So now I take and solve for X again by taking 5 times 5,000 divided by 27, and my number would be 926 grams. And that's the weight of the 15% product that I need. Okay. Continuing for the 5%, look back at the summary. For 5%, we also need 5 parts. That's 5 parts out of the 27 total equals X over the 5,000 grams again. And again, it's the same as the 15%. So if we do the same math, you should get the same number. And again, for the 5%, we also need 926 grams. My last ingredient was the 3% product. So again, I look at the summary, but here I needed 10 parts. So of the 3%. So I'm going to put 10 parts on top over the same total number of parts, which was 27, equal to X over 5,000. And once again, now if I solve for X, numerically I'd get 1,852 grams, and that represents the weight of the 3% product. So I've essentially completed these calculations. I know the weight of each of my ingredients. So just to summarize, what we've calculated is that I need 1,296 grams of my 20%, add that to 926 grams of 15%, add that to 926 grams of 5%, and lastly, add 1,852 grams of my 3%, mix all of that all together, and when I'm all done, if you add all those weights up, you can see the total weights equal 5,000 grams, and as we've proven with our alligation method, the final concentration of our product would be 10%. And that essentially ends this question, which was, again, an involved question where we had 4 different concentrations, but using the alligation alternative method in pairs. That is, 2 pairs. One in each pair had a strength higher, and each pair had a strength lower than our target. And combining those total parts together and then using the parts to derive the actual weights, we were able to solve this question. Well, that ends our practice with alligation alternative methods using 3 or more ingredients. So hopefully you understand that. And hopefully you also saw that it was essentially an alligation alternative method at its core, just coupled and paired up with each of the multiple ingredients. Let's continue, though, to practice with what my experience is much more common, which is simply to use the alligation alternative method with 2 ingredients. That's usually sufficient to be able to produce the concentrations that you normally need. So let's continue to do some practice problems to make sure, though, that you are good at your core at being able to conduct these sort of alligation alternative calculations. So to that end, let's start with this problem. It says, a pharmacist has compounded 30 grams of an ointment that contains 0.5% mupirocin. However, the patient now needs a strength of 1%. And again, mupirocin is an antibiotic. It's sold under the brand name Bactroban. It's used for a variety of different skin infections, and even oftentimes in the nose to treat kind of staph infections. So commonly used bacterial antibiotic, and it oftentimes is needed in different concentrations depending on the kind of infection. So now let's read the actual part 1 of this question, and it says, how much of this Bactroban ointment containing 2% mupirocin should be added to the compounded ointment to raise the concentration to 1%. So, fairly straightforward. We have a 0.5% concentration that we've already made. We have our stock concentration, which is 2%, and we want to combine them in a ratio so that we can end up with a final concentration of 1%. Okay, so how would we do this? Well, we would do this using, certainly we could do it multiple ways. Let's do this one using the Alligation Alternative method to make sure we're still good at that technique. Well, let's set up our alligation like this. Let's start with our high strength, which was our 2%, and that's on the upper left-hand side. Directly below that and down a ways, we'll put our low strength, which is the one we had already compounded, which was the 0.5%. And to the right and in the middle is our target concentration, which we said our desired target is 1%. Okay? So, starting at the 2% and following the arrows down diagonally from upper left to lower right, we would cross subtract. So 2 minus 1 gives us 1 in the lower right. And doing the same thing from the 0.5%, following the arrows diagonally up from lower left to upper right, we would take the 1 minus the 0.5 and put a 0.5 across from the 2. Okay? Now, I'll remind you what we would next do, now that we know we need 0.5 parts of the 2% and 1 part of the 0.5%, I still need to know the relationship of those individual parts to the total. So how many total parts would we have? So let's just add them up. The 0.5 of the 2% and the 1 from the 0.5% means our total number of parts would be 1.5. So let's set a proportion of that we need for the 2%. We need 0.5 out of 1.5 parts to be the 2%. And in the bottom, we show that we need 1 part out of 1.5 parts to be the 0.5%. So now that I've set up my ratios, where do I go from here? And this can be kind of tricky, but let's look at what it says in the question. It says that I already have 30 grams of the 0.5%. So I know how much weight of the 0.5% mupirocin I have to start with. So let's start it down at the bottom at the 0.5%. And let's use its ratio that I know that I need 1 part of the 0.5% out of 1.5 parts total. I can set that equal to, well, I know the weight of my 1 part of the 0.5% because I'm starting with 30 grams of that concentration. So my 1 part for the mupirocin, 0.5%, is equal to 30 grams, and I can set that over to X, and X represents the total weight that I don't know. I know how much 0.5% mupirocin, I have 30 grams of that, over X, the total that I need to compound. So now I can solve for X algebraically by taking the 30 times the 1.5 and then dividing it essentially by 1. And you can see that solving for X equals 45 grams, and that represents the total weight. So if I use 30 grams of 0.5% mupirocin, the total weight I'm going to need to get would be 45 grams. Okay. Now that I know the total weight, I can go back up to my 2% proportion because I know I need half a part of the 2% for every 1.5 parts of the total. I now know what the total is. I just solve for that. So I can set that equal to some X amount of the 2% over the total I know I have to get, which is 45 grams. So now I can solve for X by taking 0.5 times 45 and dividing by 1.5, and I see my final answer for this part of the question would be that I would need 15 grams of the 2% mupirocin. And that answers the question about how much Bactroban 2% ointment needs to be added to the 30 grams of the 0.5%. When I squish all that together, I get 45 grams total. And again, that would have a total concentration of 1%. And that answers this question. All right, let's stay with this same problem, but let's move on to a different part, because it turns out now that we've combined our 2% with our 0.5% to make essentially 45 grams of our 1%, here's something we didn't already know. It says that the initial 30 grams of our 0.5% mupirocin ointment also contained 0.025% of beta-methasone valerate. What will the final concentration of beta-methasone valerate be after making the 1% mupirocin? And again, it reminded us that when we added our 2% to make our 1%, that 2% did not contain any any betamethasone. So the only betamethasone we had was what was already in this 0.5% concentration. Okay, so while we were fortifying or enhancing the concentration, or increasing, I should say, the concentration of the mupirocin from 0.5% to 1% in the previous allegation question, I love this question. What this is a dilution. That is, we had a concentration we started with, the 0.25% betamethasone. When we added our additional mupirocin, we didn't add any additional betamethasone. We essentially diluted its concentration. So the mass of the betamethasone didn't increase. Essentially, the concentration will have decreased. And so the question is asking, what is the new final concentration of betamethasone in your product? So this is not an allegation question. Let's go back and solve this one. This is a dilution question. So let's solve it algebraically, okay? Because we know the mass of the betamethasone before and the mass of the betamethasone after didn't change, although the concentration does, but the mass didn't. So let's set this up with using our C times Q equals mass kind of algebra. So let's use the first C1Q1 to be what we had in the beginning, before we added any additional mupirocin. So the concentration 1 is what we had to begin with, was 0.025% weight per weight. And what we had in that original ointment was 30 grams. So our mass 1 was the 0.025% times the 30 grams. What happened after we did the combination is that our C2, our concentration afterwards, is what we don't know. It's what we're solving for. So let's set X equal to the percent concentration weight per weight of betamethasone valerate after the combination. But we do know the quantity. We know from our previous example that when we mix everything together, the final quantity will be 45 grams. So we know the mass 2 afterwards is going to be X percent times 45 grams. So now that we've set those up, we can use the idea that we know that the mass didn't change. We didn't add any betamethasone valerate. So the mass before is going to equal the mass after. So we can say that 0.025% times 30 grams is equal to X percent times 45 grams. Let's double check that we got the same units, percent, grams, grams. So now let's drop the units and simply take 0.025 times 30, and we would get 0.75 on the left, equal to 45 times X is 45X. So to solve for X, we divide both sides by 45, and our final numeric answer then would be 0.017, and the units would be percent. So then that answers this question. What we've been able to identify using, again, the algebraic method here is that by combining the additional mupirocin with our original ointment, then our final resulting concentration of betamethasone valerate would be 0.017%. All right, well, let's move on to a new problem. So this problem involves the commercial product Androgel, and it says that Androgel contains 1% weight per weight concentration of testosterone in this kind of carbomer and ethanol gel base, and this gel is to be applied every 24 hours. So the first part of the question says that according to the package insert, approximately 10% of the applied testosterone dose is actually absorbed across the skin in the 24-hour period. Therefore, if a packet contains 5 grams of gel is applied to the skin, how many milligrams of testosterone will actually be absorbed in that 24 hours? Okay. And I like this question. There's a lot of things going on here. There's the 24-hour period. There's the 1% concentration. And then there's also a percent absorption rate, kind of, if you will. So where do you start with? These are always more difficult. And I guess where you need to start is how much gel is placed on the skin. The weight of the gel is the source of the testosterone. We can then use its concentration and figure out exactly how much, and then we can use the absorption to figure out how much is absorbed. But we need to start with what is our source of testosterone to begin with, and where we would start with is the fact that we have 5 grams of this gel. So the weight of the gel applied to the skin. Now, the gel was 5 grams. But not all of that was testosterone, right? So our first conversion would be to convert from the weight of the gel to the weight of the testosterone contained within the gel. So let's take our 5 grams and multiply it by the concentration we were given as a 1% weight per weight. And we know by now that 1% weight per weight means 1 gram of testosterone for every 100 grams of the gel, because it's a weight per weight. So if we multiply it in that way, where we have 1 gram of testosterone on top over 100 grams of gel, my units of grams of gel cancel, and I'm now in the units of grams of testosterone. Okay, that's so far so good. That's the total amount of testosterone applied to the skin. That's not how much is absorbed. So let's multiply it by the fact that we know that 10% of what is applied to the skin is absorbed. So let's multiply it as that 10% expressed as 10 grams of testosterone absorbed for every 100 grams of testosterone applied. Okay? So my grams of testosterone applied cancel, and now I'm in grams of the actual amount of testosterone absorbed. And the last part of this question was, well, instead of expressing it in grams, it wanted to know how many milligrams. So let's just multiply now by the fact that there's 1,000 milligrams for every 1 gram. My units of grams cancel, and my last answer unit-wise would be in milligrams of testosterone absorbed. So if you do that math all the way from left to right, all the way across, you would end up with the numeric answer of 5, meaning that 5 milligrams of testosterone is actually absorbed from applying 5 grams of this gel over a 24-hour period. We end up absorbing 5 milligrams of testosterone, and that's the answer to this first part of this question. Part 2 of the question about androgel asks, how much testosterone should be added to the 30 gram of gel to increase its strength to 1.5%? So remember, we've already got 30 grams of gel that has 1%, but we want to add pure testosterone to increase its concentration to 1.5%. All right. Once again, you can do this a couple of different ways. Let's continue, since we're practicing our alligation alternative method. Let's approach this as an alligation alternative method, and let's set up our allegation. What of our two ingredients? We have pure testosterone, which is 100% testosterone powder, and we have our 1% gel that we had to start with, and our target is our 1.5% that we want to make. So to set up the allegation, we would start with our 100% on the top left, and then directly below that and down a ways, we have our lower strength, which is our 1% gel that we're having to begin with. And what we want, our target, which is the 1.5%, is placed in the middle, slightly to the right. So starting with the top left with 100%, let's follow the arrows diagonally down and cross subtract. So 100 minus 1.5 is 98.5. Doing the 1%, following the arrows diagonally to the lower left to the upper right, we would take 1.5 minus 1 gives us 0.5. Okay? And then to determine the total number of parts, let's add those individual parts together. So 0.5 plus the 98.5 gives us a total of 99 parts. So the proportions that we set up essentially say that we need 0.5 out of 99 parts to be 100% testosterone, whereas we need 98.5 out of the 99 parts to be the 1% gel that we already have. Now that we have that, we can try to solve for this. So what other information do we have is that we are starting with 30 grams of our 1% gel. That's the amount of gel, that's 1%, that we're going to start with. So what we can do is set that. That's really the same as our 98.5 parts. So let's start at the bottom with our 1% gel and say that if we need 98.5 parts of that gel out of the 99 total, let's set that equal to the 30 grams of gel that I am starting with over X. And X will represent the total weight of the combination. So if I solve for X, doing the algebra to solve for X, X would end up equaling 30.15 grams total. So the 30.15 grams represents the total weight of the combination of both the testosterone and the 30 grams of our gel that we started with. Okay, since that's the same total that we would have up on top, let's use our upper proportion to say that we need 0.5 parts of testosterone out of the 99 total. Set that equal to some X, essentially grams of testosterone, over the weight total that we just solved for, which was the 30.15. Now if we solve for X, we can see that X is equal to 0.15 grams of testosterone. Okay, and that answers this question. What we know now is to add 0.15 grams of testosterone to our 30 grams of 1% gel. If we mix that all together, what we would end up with was a 30.15 grams of gel that has a concentration of 1.5%. And that answers this final part to our testosterone question. All right, let's move on to our next question, which reads, Neoral oral solution contains 100 milligrams per milliliter of cyclosporine. And you can see that kind of picture down in the bottle here, or the bottle picture on the right. We have 100 milligrams per mil concentration of this cyclosporine, which is the brand name has Neoral. And just so you know, Neoral is used for organ rejection. When we transplant an organ, we want the body to not reject that organ. So cyclosporine is actually a pretty strong immunosuppressant to keep the body from rejecting this new organ that's been transplanted. So that's why a lot of people who need to be on this medication are the ones that receive the transplants. So having said that, now that's the solution we have. What does the pharmacist want to do? They want to prepare 30 milliliters of an oral solution that contains only 10% cyclosporine. So the question is, how many milliliters would you need to dilute this concentration to be able to make that? Well, that's okay, different question. Well, if we know we want it to 10%, we've got 100 milligrams per mil, let's get the same units here. So let's start off by converting our concentration of our existing solution to whatever concentration it is in percent so that we can then decide what we need to do. So let's start with converting 100 milligrams per mil to a percent concentration. Since a percent concentration is the grams per 100 mils, let's start with 100 mils. So if I had 100 mils of this solution, let's multiply that by its concentration, which we said is 100 milligrams per mil. That way the units of milliliters cancel, and now I'm in milligrams. But let's convert it to grams. So I'd take my milligrams times the fact that there's in 1 gram, there's 1,000 milligrams. So my milligrams units divide. And I see that if I had 100 milliliters of this solution already, it would provide me 10 grams. That means 10 grams for every 100 milliliters. Now, wait a minute. 10 grams per 100 milliliters is by definition 10% weight per volume. What are we trying to compound? 30 milliliters of a solution that contains 10% cyclosporine. Wait a minute, we already have that. Guess what? We don't have to do any work at all. There's no diluent needed. Hopefully you saw that, because 100 milligrams per mil is the same as 10% weight per volume. So this was a trick question. Yes, I'm not above doing that. So the good news is here, we don't have to do any more work. This solution is already 10%. We just pour out 30 mils and we're done. All right, last question, and no tricks, I promise. This one will end up this lecture, and it's got 2 parts to it, and I know this question always makes my head itch. But anyways, the problem reads, a pharmacist wants to compound 4 fluid ounces of a shampoo that contains 1.6% weight per volume of crude coal tar using the following 2 products. What volume in milliliters of each product should be used? And an important note is that 10% volume per volume of coal tar solution is equivalent to 10% weight per volume of the crude coal tar. All right? So, essentially, we want to combine 2 shampoos together to give us the right concentration of crude coal tar. All right? What are our 2 ingredients? We have the Tartan shampoo, which has 2 ingredients in it. It has coal tar solution at a 5% volume per volume concentration and salicylic acid at a 2% weight per volume concentration. That shampoo we want to combine in the right concentrations or the right amounts with the XebT shampoo, which has a 10% volume per volume of coal tar solution and 4% of salicylic acid as a weight per volume. So we have 2 shampoos, each of which has 2 ingredients. For this question, the relative amounts of the 2 shampoos that we're going to do are so that we can get the right amount of coal tar solution. So we're not worried about the salicylic acid while it's still there. The relative amounts will be defined by the amount of coal tar we need. And just to clarify before we move on, the coal tar in the shampoo is given to us as its percent volume per volume of the solution, but our desired target is going to be as a 1.6% weight per volume of crude coal tar within that solution. So that's going to make life a little more difficult here too. Not too much, but we'll have to take that into account. So where do we start? Let's just do this one step by step. First of all, let's get rid of the 4 fluid ounces. We need to be in milliliters. So my first step would be, okay, what total amount of shampoo, that when I combine these 2 together, the total amount I need is going to be 4 fluid ounces. Let's convert that. So 4 fluid ounces times the fact that there are 30 milliliters for every 1 fluid ounce. Fluid ounce cancel. And really what I'm saying is I need to compound 120 milliliters total of my 2 shampoos combined together. Okay? Now, Since all of my concentrations of the coal tar in my shampoos are expressed in volume per volume of the solution, let's change my target. It would be a lot easier to go from my 1.6% weight per volume of crude coal tar to actually tell me, okay, what actual amount of solution concentration, volume per volume, would that be equivalent to? And I can do that because my note tells me that a 10% volume per volume coal tar solution is equivalent to a 2% weight per volume concentration of crude coal tar. So let's set that up as a proportion. And I set that up as my crude coal tar 2% weight per volume on top over the equivalent concentration of the coal tar solution, which was 10% volume per volume. So 2% weight per volume over 10% volume per volume. That comes straight from the note we were given from the conversion. But that's the conversion factor I can use, because what I'm going to do is set that equal to my target, which I was given as 1.6% weight per volume. So I set that on top over X. And X would represent the percent volume per volume. So if I now solve for X by taking 1.6 times 10 and then dividing that by 2, I see numerically X is equal to 8, and 8 represents the 8% volume per volume of the coal tar solution. That's my target. Since I now have my target in the same units as the concentrations I have in my products, I can actually approach this problem, because you can see I have one shampoo that has 10% volume per volume coal tar, and one shampoo that has 5% volume per volume coal tar solution. And what I want now, I've just solved for the fact that I need something in the middle, which is an 8% volume per volume. Oh man, that sounds so much like an allegation alternative question. I think that's the way we should solve it. So let's set up our allegation. So the shampoo with the high concentration had 10%. So I'm going to put 10% on the top left, and directly below that and down a ways, I put my lower concentration, which was my 5%. And then in the middle to the right, I set my target concentration, which was 8%. So now, starting with the upper left, following my arrows down diagonally to the lower right, I take 10 minus 8, and I get 2. Doing the same thing from the 5%, following the arrows up diagonally from lower left to upper right, I would take 8 minus 5 to get 3. Now to find the total number of parts, I just take my two answers, my 3 plus my 2, and get a total of 5. So what I can see at the 10%, following the dashed arrows from 10%, what this formulation needs is 3 parts of the 10% out of a total of 5 parts. On the bottom, I can see I need 2 parts of the 5% out of the total of 5 parts. And that combination, that proportion, would give me the right concentration to be 8%. So now I need to get out of parts and get to actual volume. What I know is that the total volume of my product needs to be 120 milliliters. Okay, so I can use that for both proportions. So if I start up on top with my 10%, I know I need 3 parts out of the 5 parts to be the 10% solution. So I set that equal to some X milliliters of the X sub T over the 120 milliliters total of my combined shampoo. That's the total volume I'm going to get. So if I solve for X by taking 3 times 120 divided by 5, X equals 72. And that 72 represents the milliliters of the X sub T shampoo I need to use. Let's go down to the bottom, to the 5%. I need 2 parts out of the total of 5 parts to be my Tardan shampoo. Set that equal to X milliliters. I don't know exactly how many milliliters of the Tardan, but I know that the total combined will be 120 milliliters. So now if I solve for X, I take 2 times 120 divided by 5. I get a total value of 48, and that would be milliliters of the Tardan shampoo. And that answers this question. If you think about it, it wants to know the volume of each shampoo to combine. So if I take 72 milliliters of my 10% X sub T shampoo and mix it with 48 milliliters of my 5% Tardan shampoo, the total volume would be 120 milliliters, and the total concentration when we've combined that of the coal tar solution would be a final concentration of 8% volume per volume. And that essentially answers this part of the question. All right, the last part to the last question is this. What is the resulting concentration of salicylic acid in the final combined shampoo? So The question we just answered was to figure out the proportions of the two shampoos to combine so that we could get our exact target amount of coal tar solution, which was the 8% volume per volume. So having done that now, what this question wants to know, well, since you have different amounts of two different concentrations of salicylic acid, what will the final concentration of salicylic acid be in this combined shampoo? So how would we handle this? Well, we had a certain concentration and volume of one shampoo to another concentration and volume of a different shampoo, and we made a third concentration or a unique concentration with the combination. So that sounds like a perfect type of algebra formula to create. So let's use our C's and Q's to create masses, because in the end, our new shampoo will have a different mass than our two individual ingredients had to begin with. So again, we will have essentially a fortification. The 2% is going to go up since we're combining it with the 4% of salicylic acid. So let's do our CQs and our masses. So let's set up the first concentration equal to our concentration of our tartan shampoo. So we said now, and let's focus on the concentrations. In this calculation, we're calculating for salicylic acid. So the concentration of salicylic acid in the tartan shampoo was 2%, and it was a weight per volume. What quantity of that shampoo are we going to use? We know that now since we have to use a certain volume to get our coal tar concentrations. We just calculated that the volume we would use would be 48 milliliters. So the mass of the salicylic acid from the tartan shampoo would be its 2% times its 48 milliliters. Now let's do the same thing for the XZT shampoo. Its concentration in the shampoo already was 4% to begin with. The quantity of that shampoo we're using is 72 milliliters. So the mass of the salicylic acid in that shampoo would be its 4% times its 72 milliliters. Now let's set that equal to our final combined shampoo. So the concentration of salicylic acid in that final combination, we don't know, so we'll set that as X. So X is the percent weight per volume of salicylic acid in the combined shampoo. But we do know what the final quantity is going to be. We know we're calculating we're going to have a total volume of 120 milliliters. So the concentration, or the mass, I should say, of salicylic acid in our combined shampoo will be some X% times 120 milliliters. So since we know mass of 1 plus the mass of the 2 is going to equal the final mass in our final shampoo, let's say that 2% times 48 mils plus 4% times 72 mils is going to equal our X% times 120 mils. Quick check to make sure our units are the same, percent, and mils, mils, mils. So let's drop the units and just do 2 times 48 to get 96. Add that to 4 times 72, which is 288. And set that equal to X times 120, which is 120X. So if we do the addition on the left, we see we have 384 equal to 120X. Let's divide both sides by 120, and we see that our number is 3.2. And remember, X equaled the percent concentration of weight per volume of salicylic acid in the final shampoo, which we now know to be 3.2%. And that's the final answer to this question, and that's the final question of this lecture. So hopefully you found this as a useful review of a lot of the different ways that we have been figuring out how to calculate adjusted drug concentration. Whether we use the algebra method or the alligation alternative method, you must be skilled in both of those and apply them when they're most appropriate to different kinds of problems. And hopefully this lecture was helpful.